This video is a STAAR review on Rule of 4. Rule of 4 is just 4 different representations of linear relationships. The 4 different representations are graphs, situations, equations, and tables. When given one of the representations, you should be able to take that, such as the situation, and write an equation, make a table of values, and be able to graph it. So as we go through our examples, please make sure you pause the video when needed so that you can take good notes. On our first example, we're given the situation. Jenny earns $8 an hour working part-time at the supermarket. Determine how much she will earn in 8 hours. We can turn the situation into a table, but first we need to identify the x and the y values. Remember, x is our independent variables and y is our dependent variables. This means that the value of y depends on x. You have to know x in order to determine y. So in our problem, we're comparing how much Jenny earns to how many hours that she works. Which one is the independent? Which one is the dependent? Well, the number of hours, you have to know the number of hours she works to determine how much she's going to make. So the hours is going to be our independent, so that'll be our x. I'm going to put hours. And how much she earns, the money she earns, will be our y. That's our dependent. You have to know how many hours she works in order to determine how much money she's going to earn. Okay, tables. Most tables have this middle column, this process column. Some do not, but this process column is where you say, okay, what process, what operations do I have to do to x in order to get y, to find y? So my suggestion is, if your table does not have a process column, is to kind of add one over here on the end. This is a great place for you to show your work to make sure you don't make any mathematical mistakes. All right, so our process, going back to our situation, what do we have in here that tells us what to do? Well, it tells us that she earns $8 an hour. So that operation is multiplication. So our process is to multiply the 8 times the number of hours, x. So our process is 8 times x. Some tables will give you x values and want you to determine y. Some tables do not. You get to choose your own x values. So we're going to choose the x values. I'm going to start with 1 hour. And the reason is because my graph is small. It's not a real big graph, so I can't get into larger numbers. I'm going to have to keep them small. So my process, if I substitute 1 for x, my process is going to be 8 times 1, which is going to give me 8. So if she works 1 hour, she earns $8. If she works 2 hours, my process would be 8 times 2, which would give me the $16. If she works 3 hours, my process is 8, and I replace x with 3. 8 times 3 is 24. So if she works 3 hours, she makes $24. I can then go and turn this into an equation. Equation is really easy. Remember, equation has an equal sign in it. All I have to do is take my process, 8 times x, 8x, and put a y equals in front of it. I'm solving for y. Y is going to equal this process, 8 times x. So there's my equation. Super simple. Now the fourth representation is to graph it. Before I can graph it, I have to have an ordered pair. As you will recall, ordered pairs are the x and the y coordinates. Alphabetical order, x comes first. So you just take the x and y values from your table. When x is 1, y equals 8. When x is 2, y equals 16. When x is 3, y equals 24. Now that you have your ordered pairs, you can go and graph them onto your coordinate plane. After you graph the points, you'll want to connect it with a straight line. So this is what the graph looks like. As you can see, you can actually continue the line showing more hours and earning more money. As she works more hours, she earns more money. But when I continue the line, it stops at the y-axis. Why does it stop there? If I were to continue, it would go into negatives, and she's not going to work negative hours or make negative money. That's unrealistic, so there's no sense of even extending it. Another thing I want to kind of jog your memory about, just look right here. Where does my line stop on the x-axis? It stops at this point. Do you remember what that's called? The origin. So we talked about this. If a linear graph goes through the origin, it is called a multiplicative relationship. And which makes sense because if you look at a process, we're only multiplying, right? So this is a multiplicative relationship. You need to remember that. Anytime the graph goes through the origin, it's multiplicative. Okay, let's look at our next example. Susan is 2 when her sister is 5. Susan is 3 when her sister is 6. Find Susan's sister's age, A, when Susan is N. Okay, so in our table, we're not really given a process. Instead, we're given X and Y values. So let's determine the independent. What do you have to know? Do you have to know Susan's age, or do you have to know her sister's age? Hopefully you said you have to know Susan's age. So that would be the independent Y, and then her sister, and I'll put cis, I'm sorry, independent's the X. Her sister is Y, the dependent. So we don't know the process yet, but let's go fill in the values that we do know. We know that when Susan is 2, her sister is 5. So Susan is 2, her sister is 5. When Susan is 3, her sister is 6. So Susan is 3, her sister is 6. How old do you think her sister will be if Susan is 4? Well, if you follow the pattern, it would be 7. What about if her sister was 5? Again, follow the pattern, and you would get 8. So what is the process? Can you tell what we're doing to X in order to equal Y? Yeah, we're adding 3. So the process is to add 3, X plus 3. Try it. If I use 2 for my X and I add 3, that gives me 5. If I take Susan is 3 and I add 3, I get 6. If I take 4 and I add 3, I get 7. If Susan is 5 and I add 3 to her age, I get 8. So the equation, same as before, you take your process, X plus 3, and you just add a Y equals to it. And let's graph it. Write your ordered pairs, 2, 5, 3, 6. When X is 4, Y is 7. When X is 5, Y is 8. And then you graph it, connect it with a straight line. Oops, come on. It doesn't want to pop up, does it? There we go. Okay, this time, what do you notice about where it hits on the y-axis? Is it hitting the origin? No, it does not. So when a linear graph does not go through the origin, it is called an additive relationship. Which makes sense because if you look at the equation, we're adding, aren't we? We're not multiplying, we're adding. So this is an additive relationship. Those are two things you need to make sure you remember. If the graph goes through the origin, it's multiplicative. If the graph does not go through the origin, as in this case, it is an additive relationship. Okay, I just want to talk about going from tables to equations very quickly. A lot of times you're just going to be given a table of X and Y values, and they're going to ask you to find the equation. What equation represents this table? The easiest way to find the equation is to use the rate of change. We've talked about this in class. The rate of change is the change in Y over the change in X. So let's go ahead and try it out. Start with the first table. Oh, before we can try it out, what does the rate of change represent? Remember on our equations, we had the first one was Y equals 8X, and the second one was X plus 3. The rate of change tells you your coefficient to X. It tells you what you're multiplying X by, or how many X's you're going to have. So in this equation, the coefficient is 8. That is our rate of change. In this equation, there's not a number in front of X. There's not a coefficient. There actually is. It's invisible. It's really a 1X. So the coefficient is really 1. That's your rate of change. That's going to be your coefficient to X. So let's go ahead and try it. Rate of change is going to be the change in Y. So if I go from 12 to 18, my change is that I'm increasing by 6. So that's my rate of change, 6. And my change in X, if I go from 2 to 3, my change is it's increasing by 1. So my rate of change is 6 over 1, which I can simplify to just 6. This is my coefficient. So for my equation, it's going to be Y equals, and I know my coefficient to X is 6, so it's going to be 6X. But I don't know if this is multiplicative or if it's an additive relationship, so I need to plug in some numbers to see. So I'm going to use a 3. If I use a 3 for x and I plug it in, 6 times 3 is going to give me 18. Is that what I want y to equal? Yes. But I don't stop there. I check one more just to make sure I'm on the right track. So I'm going to use 5 for x. If I do 6 times 5, that gives me 30. Is that what I want y to equal? Yes. So this is it. I don't need to do anything else to my equation. It is a multiplicative equation. Y equals 6x. Okay, let's try the next table. We come over here. We do the same thing, find your rate of change. Find your change in y. Well, if I go from 10 to 13, my change is a plus 3. I'm going to erase this down here so I have some room to write. And my change in x from 4 to 5 is a plus 1. So my rate of change is going to be 3 over 1, which simplifies to 3. This is my coefficient. So my equation is going to be y equals 3x. Now, let's see if I need to do anything else. If I plug in 4 for x and I do 3 times 4, that gives me 12. Is that what I want y to be? No. Y needs to be a 10. So what do I have to do to this 12 to make a 10? I have to subtract 2, right? So if I do 3 times 4 and then subtract 2, 12 minus 2 is 10. Let's try 7. If I do 3 times 7, that gives me 21. And when I subtract 2, does that give me 19? Yes. So to my 3x, I need to subtract 2. This is my equation. Y equals 3x minus 2. Okay, let's try the last one. Okay, here, the change in y from 7 to 15 is increasing by 8. So I'm going to have 8 as my change in y. My change in x, going from 1 to 3, it's increasing by 2. So 8 over 2. So my rate of change is 8 over 2. And I can simplify this. 8 divided by 2 is 4. This is going to be my coefficient. So my equation is going to be y equals 4 times x. And let's see if I need to do anything else. So I'm going to try this 4. If I substitute 4 for x, it's going to give me, I'll do it over here, 4 times 4, which is 16, but I need it to be a 19. So what do I have to do to the 16 to make a 19? Add 3. Let's try the 7, see if that works. If I do 4 times 7, whoops, that gives me 28, and if I add 3, does that give me 31? Yes. So my equation is going to be 4x plus 3. Y equals 4x plus 3. That is my equation.